Practice set 5.3. Question 1. Write sample space S and the number of sample points n of S for each of the following experiments. Also write events ABC in the set form and write n of A, n of B, n of C. Subpart 1. One die is ruled. Now let us write sample space S. S is set of all possible outcomes when we roll a die, one die. So we get 1 on the top, or 2, or 3, or 4, or 5, or 6 at the top. So this is the sample space S. Number of elements in S, n of S equals 1, 2, 3, 4, 5, 6. So n of S equals 6. Event A, even number on the upper face. So, how many are even numbers in S? 2, 4, 6. So, A is possibilities of getting even number. When we roll the die once, we can get 2, 4, 6 as even numbers. So, A in the set form is 2, 4, 6. N of A, number of sample points in A, equals 1, 2, 3. So n of A equals 3. Event B is odd number on the upper face. So in sample space S, which are the odd numbers? 1, 3, 5. So that is B. In the set form, we write as 1, 3, 5. N of B, number of elements or sample points in B is 1, 2, 3. So n of B equals 3. Event C, prime number on the upper face. Now in S, which are the prime numbers? 2, 3 and 5. So event C can be written in the set form as getting 2 or 3 or 5, 2, 3, 5 in the curly bracket. N of C, number of elements or sample points in C equals, they are 1, 2, 3. So N of C equals 3. Subpart 2. Two dice are rolled simultaneously. Let us write down S. Sample space S is, you can get 1 on the first die and 1 on the second, or 1 on the first and 2 on the second, or 1 on first and 3 on second, and so on. So 1, 4, 1, 5, 1, 6, or you may get 2 on the first one, 2, 1, that is 2 on the first, 1 on the second, 2 on the first die, 2 on the second, and so on. So 2, 3, 2, 4, 2, 5, 2, 6. Now you may get 3 on the first die, 3, 1, that is 3 on the first dice, 1 on the second. 3 on the first dice, 2 on the second. 3 on the first dice, 3 on the second, and so on. So 3, 4, 3, 5, 3, 6. Next, you can get 4 on the first dice, 1 on the second. So let us continue similarly. 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. You may get 5 on the first dice. So 5, 1, 5, 2. That is 5 on the first dice, 2 on the second. 5, 3, 5, 4, 5, 5, or 5, 6. Lastly, you may get 6 on the first die and 1 on the second dice. So 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So this is the sample space S. Now how many sample points are there inside? If you'll count 1, 2, 3 and so on up to 6, 6, there are 36 points. So n of S equals 36. Event A. The sum of the digits on the upper faces is multiple of 6. What does that mean? Addition of the two numbers should be multiple of 6 means 6 or 12 because maximum addition possible is 6 plus 6, 12. So, where does the addition come to be? Multiple of 6. 1 plus 5, 6. 2 plus 4, 6. 3 plus 3, 6. 4 plus 2, 6. 5 plus 1, 6. 6 plus 6, 12. These are the possibilities. So, A, event A, in the list form can be written as 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 6, 6. How many sample points are these? 1, 2, 3, 4, 5, 6. Therefore, n of A equals 6. B. The sum of the digits on the upper faces is minimum 10. It means the addition of the two numbers has to be either 10 or 11 or 12. That is meant by minimum 10. So where is this possible? In the sample space S. It is possible when we have 4, 6 addition 10, 5, 5 addition 10, 5 plus 6, 11, 6 plus 4, 10, 6 plus 5, 11, 6 plus 6, 12. So these are the possibilities. Therefore, event B in the list form is given by 4, 6, 5, 5, 5, 6, 6, 4, 6, 5, 6, 6. How many sample points are there in B? 1, 2, 3, 4, 5, 6. Therefore, n of B equals 6. Event C. The same digit on both upper faces. So in sample space S, where is it possible? At 1, 1, same numbers. 2, 2, both upper faces same digits. 3, 3, 4, 4, 5, 5, 6, 6. So let us write down C. C equals 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. How many sample points are there in C? 1, 2, 3, 4, 5, 6. Therefore, n of C equals 6. So part 3. 3 coins are tossed simultaneously. So let us write down first sample space S. There are 3 coins. Either we can get head or tail on the first, head or tail on the second, head or tail on the third. So let us write down possibilities getting 3 heads or 2 heads. How can we get like this? HHT, HTH, THH. Or we can get 1 head. So HTT, THT, T, T, H. Or we can get 0 heads, means all tails. So this is the sample space S. How many sample points are within? 1, 2, 3, 4, 5, 6, 7, 8. So n of S, number of sample points or elements in S, is 8. Now condition for event A. To get at least 2 heads. In S, at least means minimum 2. So we can have 2 heads or 3 heads. Where is it possible? Here 3 heads, here 2 heads, 2 heads, 2 heads. That's all. So let us write down event A in the set form. A equals H, 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 T, H, T, H, and T, H, H. Number of sample points in A, 1, 2, 3, 4. Therefore, n of A equals 4. Condition for event B is to get no head. That means we should get all tails. Where is that possible? All tails means no head. Here in TTT in S. So let us write down event B in the set form. B equals T, T, T. So n of B, obviously only one element is there inside, so n of B equals 1. Condition for event C. To get head on the second coin. So in S, where do we get head on the second coin? Here in HHH, HHT, THH, THT. That's all. Therefore, let us write down C in the set form. C equals getting head on the second coin equals HHH, HHT, THH, THT. Number of sample points in C equals 1, 2, 3, 4. So n of C equals 4. Sub question 4. Two-digit numbers are formed using digits 0, 1, 2, 3, 4, 5 without repetition of the digits. So let us write down the sample space S. Now remember here, without repetition means we can't have the numbers 11, 22, 33, 44, 55. Moreover, we want two-digit numbers, so we cannot start with number 0. So the sample space S will be, I have written here now, it will be 1, 0, 1, 2 means 12, 13, 14, 15, 20, 21. Now we can't have 22, so 23, 24, 25, 30, 31, 32, 34, 35, 40, 41, 42, 43, 45, 50, 51, 52, 53, 54. So, n of S, the number of elements in sample space S. If we will count 1, 2, 3 and so on, there are 25 numbers. Hence, n of S equals 25. Now, let us see event A. Condition for event A is the number formed is even. So let us see S again. Which are the even numbers? Numbers are 10, 12, 14, 20, 24, 30, 32, 34, 40, 42, 50, 52, 54. So we have written here A in the set form 10, 12, 14, 20, 24, 30, 32, 34, 40, 42, 50, 52, 54. How many are these numbers? Sample points in A. They are, if you count, they are 13. So n of A equals 13. Now let us go to subpart B. For event B is the number formed is divisible by 3. So in S, which are the numbers which are divisible by 3? Now if you remember, the number will be divisible by 3 if the addition of the two digit comes in the table of 3. That is just a hint. But which are the numbers in S now which are divisible by 3? 12, 15, 21, 24, 30, 42, 45, then 51, 54. So we have written here B. Even B is in the set form 12, 15, 21, 24, 30, 42, 45, 51, 54. N of B equals number of sample points in B equals, if you will count 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are 9 points, hence N of B equals 9. Now condition for event C is the number formed is greater than 50. So let us now see in S the numbers which are greater than 50. They are 51, 52, 53, 54. Therefore C in the set form equals 51, 52, 53, 54. Number of sample points in C, N of C equals 1, 2, 3, 4. That is N of C equals 4. Sub-question 5. From 3 men and 2 women, environment committee of 2 persons is to be formed. So let us write sample space S. There are 3 men, let us call them as M1, M2, M3. Let me change the color of the pen so that it will be visible. Okay, M1, M2, M3 are men and women, let us call them by F1 and F2. Now when we are forming committee here, out of 5 we are selecting 2. Remember M1, M2 and M2, M1 are same. Means male 1 and 2 getting selected, or writing male 2 and male 1 getting selected is the same. So considering that, we are going to write the sample space S. S is given by M1, M2. So you are selecting M1, M2 or M1, M3 get selected, or M1, F1 or M1, F2 or M2, M3 get selected, or M2, F1 or M2, F2 gets selected, or M3, F1 gets selected, or M3, F2 gets selected. And the last option is F1, F2 gets selected. So again, sample space S is M1, M2, M1, M3, M1, F1, M1, F2, M2, M3, M2, F1, M2, F2, M3, F1, M3, F2, F1, F2. Number of elements when we count in the sample space, they are 10. Visibly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So N of S equals 10. Condition for event A. There must be at least one woman member. So let us try to write down the event A in the set form. Now at least one woman is where in M1 F1, M1 F2, M2 F1, M2 F2, M3 F1, M3 F2 and F1 F2. At least one means one or two. Event A in the set form is M1 F1, M1 F2, M2 F1, M2 F2, M3 F1, M3 F2 and F1 F2. N of A, number of sample points or elements in A is 1, 2, 3, 4, 5, 6, 7. Therefore, N of A equals 7. Condition for event B is one man, one woman committee is to be formed. Now let us write event B in the set form. One man, one woman. Where is it possible? Let us write down B now. In M1 F1, then M1 F2, then M2 F1, M2 F2, M3 F1, M3 F2. These are out of sample space S possibilities where we have one man and one woman in the committee. So number of points in B. 1, 2, 3, 4, 5, 6. So N of B equals 6. Now let us go to third part. Condition for C. Condition for event C is there should not be a woman member. Okay. No woman means all males. So C we will write here. M1, M2. We don't want females, no women. So M1, M2, M1, M3, M2, M3. That's all. Where? See again the condition. There should not be a woman member. So here in S M1, M2, M1, M3 and M2, M3 there are no women. So that is what is C. N of C, number of elements in C, event C are 1, 2, 3. So N of C equals 3. Sub question 6. One coin and one die are thrown simultaneously. So let us write down sample space S. We have one coin. It shows head or tail. We have one die which shows numbers 1 to up to 6. So S equals, suppose we get head on coin and 1 on dice, or head and 2, head and 3, which means head on the coin and 3 on the dice, or head and 4 on the dice, head on the coin, 5 on the dice, and so on. So H6, or tail and 1, tail and 2, tail and 3 on the dice, tail on the coin, 4 on the dice, tail on the coin, 5 on the dice, tail on the coin and 6 on the dice. So, how many members or elements are there in the sample space S? N of S equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, N of S equals 12. Condition for event A. That is part 1. To get head and an odd number. So in the sample space S, where do we see head and odd numbers? H1, H3, H5. We get head and odd number. So A, event A in the set form is H1, H3, H5. N of A, number of elements in A, sample points in A are 1, 2, 3. So N of A equals 3. Now let us go to next question in this. Question for event B is to get a head or tail and an even number. So let us see. Head or tail and even number are possible in H2, head and even number, head and even number 4, head and even number 6, or tail and even number T2, T4 and T6. So, B in the set form is H2, H4, H6, T2, T4, T6, getting head or tail and even number. N of B equals, let us count 1, 2, 3, 4, 5, 6. So N of B equals 6. Condition for event C is number on the upper face is greater than 7 and tail on the coin. Now see. Can we get the number greater than 7 on the die? The die can show the numbers from 1 to up to 6. So it is not possible to get the number greater than 7 on the dice. So C is the null set, empty set, written in curly brackets with no elements inside. That also can be written as 5. So number of elements in C equals 0. We also call it as an impossible event. Friends, thank you for watching the channel Best Readouts.